Hello Year 11. Welcome to the third lesson about rate of reaction, and today we're going to look at things that will change the rate of a chemical reaction. We're going to start off, as we start every lesson, with a retrieval practice, and we're going to practice calculating mean rate of reaction. So, if a reaction produces 50 centimeters cubed of hydrogen gas in 45 seconds, what is the mean rate of reaction? A candle is burnt and it decreases its mass by 0.47 grams when burned for 2 minutes and 15 seconds. What is the rate of reaction? The decomposition of hydrogen peroxide reaction released 33 centimeters cubed of oxygen in 1.5 minutes. What is the rate of reaction in centimeters cubed per second? And finally, magnesium reacted with hydrochloric acid to produce 77 centimeters cubed of hydrogen gas in 300 seconds. What is the rate of reaction in centimeters cubed per minute? Okay, so what I want you to do is get a piece of paper and pause the video and attempt to do these 4 calculations. So let's have a little look at the answers. So a reaction that produces 50 centimeters cubed of hydrogen gas in 45 seconds. We're looking at the amount of product over time is 50 divided by 45, which gives 1.11 centimeters cubed per second. Candle is burnt and it decreases in mass by 0.47 grams in 2 minutes and 15 seconds. And we have a problem there because we've got 2 units present. So we need to convert that to seconds. So that is 135 seconds. So we've got 0.47 divided by 135 gives us 0.0035 grams per second. The decomposition of hydrogen peroxide gives you 33 centimeters cubed of oxygen in 1.5 minutes. What is the rate of reaction in centimeters cubed per second? So again, we need to convert that to seconds. So that's 33 divided by 90 gives you 0.37 centimeters cubed per second. Magnesium reacted with hydrochloric acid to produce 77 centimeters cubed of hydrogen gas in 300 seconds. What is the rate of reaction in centimeters cubed per minute? So we need to convert seconds to minutes by dividing by 60, and that gives you 5 minutes. So that's 77 divided by 5, and we are producing 15.4 centimeters cubed per minute. Hopefully you are quite successful with those calculations. Okay, today we're going to look at the factors that affect and can change the rate of reaction. So we're going to be able to hopefully explain what we mean by collision theory. I want you to be able to explain how changing the temperature, the concentration, surface area or catalyst can affect and change the rate of reaction, and then put your knowledge to the test by answering some past exam questions on rate of reaction. Okay, so rate of reaction and collision theory. Chemical reactions can only take place when the reactant particles collide with each other and form new products. So they have to collide. Is it really that simple? Well, sort of, because not all collisions are successful. So let's have a look at an unsuccessful collision. So those particles haven't got very much energy. They haven't got enough energy to collide, and so therefore they don't join together and form a product. So the reaction has not happened. Here's an example of a successful collision, right? So they're colliding with enough energy to actually make a product. Now we call that energy what we call the activation energy. So you have to have at least that in order for the reaction to occur, the activation energy. So here's a sort of like model to see what the activation energy is. Before we can actually go from A to B, so the reactants to the products, we have to actually put in that amount of energy there, right? So we have to roll that up to the top of the hill and use energy to actually get them to react before they can go all the way down and form the reactants. So the activation energy is the minimum energy required for the particles to react successfully. That activation energy is needed to break the bonds in the reactants and remake them again in the products. Okay, so let's have a little look at what we've learned so far. So I want you to be able to look at those two reactions and, using the collision theory, explain why the first one's not got a reaction and the second one has. What is the term activation energy? What do we mean by that? And explain what would happen to the rate of reaction if the activation energy for a reaction could actually be made a bit lower. So please, can you pause the video now and attempt those questions? Okay, welcome back. Hopefully you didn't have too much trouble with those. Okay, so in the first reaction, the reactants are not colliding with enough energy for the reaction to occur and make the products. And in the second reaction, the reactants are colliding with sufficient energy, which we call the activation energy, for the reaction to occur, so the products are formed. Define the term activation energy. Right, activation energy is the minimum energy required for a collision to occur. So it's the minimum energy the particles must have in order to collide successfully. Explain what would happen to the rate of reaction if the activation energy could be lowered. Well, if you lower the activation energy, that means that more of the particles would have the required energy, and so there would be more successful collisions and the rate of reaction would increase. Okay, so that's our first success criteria. Now we're going to look at how and what will change the rate of a reaction. Those things are temperature, concentration, surface area, and adding a catalyst. So these are the 5 factors that affect a rate of reaction: temperature, concentration of solutions, using a catalyst, the surface area. By that we mean what size of lumps we're using or whether we're using powder, and pressure if we're using a gas. Okay, so let's have a look at temperature. If we increase the temperature of a reaction, then the particles will have more energy. If they have more energy, they will move faster because it's kinetic energy. If they move faster, then there's going to be more collisions. The collisions will happen faster and they will probably collide with a lot more energy. So there'll be harder collisions and the rate of reaction will get faster. If we lower the temperature, then the particles will have less energy. They're going to move slower. So therefore, there's going to be fewer successful collisions. And if they're moving slower, they're not going to be at the activation energy. So the rate of reaction will be slower. Right, if we look at pressure, pressure only is a factor when you have gases. So if you increase the pressure, that means you're actually squeezing it into a smaller space. So if you squeeze it into a smaller space, the particles are closer together. So they're going to have more frequent collisions because they're closer, and therefore more successful collisions, and the rate of reaction will get faster. If you make it so that you're decreasing the pressure, that means they've got a lot of space and not very many particles in that space, then the particles are further apart. There are fewer frequent collisions between the particles, few of them are successful, and the rate of reaction is slower. Okay, increasing the concentration. Now, concentration means how many reactant particles have we got in a solution. So if we increase it, there are more particles in a given volume or space. So there are more frequent collisions between the particles because there's more of them. More of them will be successful and the rate of reaction's faster. And the converse, if you lower the concentration, there are fewer particles in that space, in that volume. So there's going to be fewer collisions and the rate of reaction slower. Right, surface area is a little bit more complicated to explain. If we increase the surface area, what we are actually doing is making the particles smaller. If you look here at a big lump of substance, it's only those ones on the outside that are able to react with the solution around it. And all those ones inside have to wait until these ones have reacted before they can react. So the smaller you can make the particles, the bigger the surface area to volume ratio. So there's more surface area in contact with the solution. If there's more surface area in contact with the solution, there's going to be more particles available to react and collide and more successful collisions. If you make them big, there's going to be fewer that are available to react and therefore fewer successful collisions and the rate of reaction is slower. Now if we use a catalyst basically provides an alternative route than the one that would normally be taken. And a catalyst lowers the activation energy. If it lowers the activation energy, it means that more particles will be able to collide successfully. And therefore the rate of reaction will increase. Now, a catalyst, in case you didn't know, was something that speeds up a reaction. Okay, and it lowers the activation energy. Okay, so just a reminder again, the activation energy is the minimum amount of energy the particles must have to collide successfully. Okay, so now it's your turn. What I want you to do is, on your piece of paper, write 5 sentences. These are going to be linked together, so I put them all in different colours. So we start with this stem. One of these will explain that. One of these will be a consequence of that. And then finally, the last one is you're going to say to me whether the rate of reaction's going to increase or decrease. So for instance, increase in the temperature. Now, if you think that means that there are more particles available to react, you'll say increasing the temperature means there's more particles available to react. Then say, so there are more or less successful collisions, and therefore, and the rate of reaction will either increase or decrease. Okay, so I want you to pause the video and write your 5 sentences, please. Okay, right. So here's the correct answers. First one, increasing the temperature means the particles have more energy, so there are more successful collisions and the rate of reaction increases. Decreasing the pressure means that the particles are further apart, so that there are fewer successful collisions and the rate of reaction decreases. Increasing the concentration means that there are more particles in a volume, so there are more successful collisions and the rate of reaction will increase. Increasing the surface area means that there are more particles available to react, so there are more successful collisions and the rate of reaction increases. And finally, adding a catalyst means that the activation energy is lowered, so there are more successful collisions and the rate of reaction increases. Okay, hopefully you managed to do that. Okay, now we're going to look at some past exam questions on how these factors affect the rate of reaction. Right, first exam question. If the concentration of acid used was doubled, what would happen to the rate of reaction? Now, the first thing you would want to look at, and you sometimes are asked, is to draw in another line of what you would expect the double the concentration to look like. Well, I think we've done that in a previous screencast. So where do you think it should be? Yes, you're right. It should be above the first curve because you've got a steeper gradient. You're making the product quicker, but you notice that we are still ending at the same point. So let's explain that, right? The rate of reaction happens twice at the rate and it finishes in half the time. Okay, if the temperature of the reaction was lowered, what would you expect to happen to the rate of reaction? So would you expect the line to be above or below it if it's at a lower temperature? Right, yes, it would be below it because it would be happening slower. So at a slower rate, oxygen will be produced at a slower rate. Okay, phosphoric acid is made by reacting phosphate rock with sulfuric acid. Only 3 of the methods shown will increase the rate of the reaction of making phosphoric acid from phosphate rock. Of the 3 methods, which of 3 will increase the rate of reaction? Pause the video now and write down your 3, please. Okay, welcome back. Right, the 3 methods that would increase the rate of the reaction would be to use a more concentrated solution, use powder rather than big lumps, and increase the temperature. A student planned to investigate the effect of temperature on the rate of reaction, and the student predicted that the rate of reaction would increase as the temperature was increased. Give 2 reasons why the student's prediction is correct. So pause the video now and write down the 2 that you think are correct. Okay, yes, the ones that are correct are they have more energy and they move faster. Using the graph, state one conclusion that the student could make about the effect of temperature on the rate of reaction. So pause the video now and come back when you've answered the question. Yes, so the answer is that the 40 degrees happens at a faster rate than the 20 degrees, and you could also further quantify that by saying that the rate of reaction is double the amount because it gets to its final point half the time that the other one did. A student investigated how the surface area of marble chips affected the rate of reaction. Which 2 variables should the student keep the same? Yes, they should keep the concentration the same and they should keep the mass of marble chips the same. Right, this is actually taken straight from a past paper, right? So a student investigated how the surface area of marble chips affected the rate of reaction. Which 2 variables should the student keep constant? Right, they should keep constant the concentration and the mass. Explain in terms of particles and collisions the effect that increasing the surface area of the marble chips has on the rate of reaction. Pause the video now and come back when you've answered the question. Okay, welcome back. Right, the answer is There are more particles available to react, so there are more frequent collisions and the rate of reaction increases. Right, explain in terms of particles why temperature has this effect on rate of reaction. I think by this effect we mean why temperature will increase the rate of reaction. So pause the video now and come back when you've answered it. Okay, so explain why temperature increases the rate of reaction. So any three from these answers, and this is typical for an exam question, so it allows you to give three of these answers. You don't have to give all of them, although a good answer would have all of them. Particles have more energy or higher kinetic energy. The particles move faster, but you're not allowed to say they move more or vibrate more. Therefore, there are more collisions and more energetic, successful or harder collisions. So more particles have the required activation energy. Okay, so there's a little sample of exam questions. Hopefully you've understood the lesson, and I'll see you back in the next screencast.